Okay, for today, your job was to have the odd problems done on last night's worksheet. We will look at those in a little bit. But for right now, I want you to stay focused with me on a blank notability doc as we tackle problems that are a little harder to factor. So I'm going to pause for a second. All right, so let's say we had 2x squared plus 3x plus 1. This does not have a GCF. A GCF is where it has a greatest common factor. There is nothing in common here, here, and here. But you can factor it. So if I were you, I'd start off right away by just trying to set up two parentheses. First thing you do is look for a GCF, but there wasn't one. Set up two parentheses. And if you have something like 2x squared, you don't have any choices. You have to have a 2 and a 1 to make a 2, right? So then one of these has to be 2x squared, and one has to be 1x squared, but you might as well just call it x. I said 2x squared, but I meant 2x. So 2x and x. And then you don't have many choices here. A plus and a plus. Why? Because there's only pluses in the problem. And then the only last thing is, what can that be? Well, what makes a 1? Notice I'm not trying to add to this number. I am trying to just figure out what multiplies to 1. 1 and 1. And there we go. Raise your hand if you had it right. Okay, so that was super simple. So what happens that makes this more complicated? Well, they would have a GCF in it, and the problem might end up looking like this when it's all done. And what would that problem have looked like at the beginning? Well, would you please just multiply this one out? It's kind of like backwards factoring. This is factored. Would you please tell me what it would look like? Pausing. Okay, so you should have said, I personally like to multiply this part out first. Now, can you multiply this 3 in? Yes, but don't do it to everything. Just do it to those two. So either way would have worked. But again, my favorite way is to multiply out these parentheses because I know how to do that with first outside, inside, last. All right, so I'm going to start with those two. 2x squared plus 4x, then minus 5x, and then minus 20. Then I put it all together. 2x squared plus or actually that's a minus an x, minus 20. And then this 3 has to still be multiplied in. 3 times 2 is, 6x squared minus 3x minus 60. That's what that one would have looked like at the beginning. And what would the first step have been? Take out the 3. It's kind of like going backwards. What would the next step have been? Multiply, wait a minute, it's hard to go backwards. Then you would have done your factoring and get it factored down to this and this with the 3 in front. Okay, yes sir, I bet you see a mistake. Put 4x, not 8x. Trying to figure out where that would be. Okay, you are correct. This should have been an 8x. Okay, 8x minus 5x is 3x. And then 3 times the 3 would be 9x squared. Dang it, I missed a number in there. Now, this was going backwards, so it's actually harder to check yourself. But I was going to say that on a test, I would make sure to check myself. So multiplying it out, the only way I could have checked myself is to factor it back out again. In fact, let me just show you. Just like, you all know there's times when it's really important to be careful, and there's other times that it's not. Doing a practice problem isn't a big, super important time, but a test would be. If I refactor it out, the 3 comes out of everything. 2x squared minus x minus 20. I had done that part right. And then I'd have to refactor it out again. And that's when I would have noticed, wait a minute, I can't get this thing to factor to be this. And I would have realized I had done something wrong. So this test, unlike many of your other tests, you can totally know if you're right. And when you only have 4 R3s, and if you haven't figured this out yet, the R3s are where it's all at. Yes, the R2s are kind of important, but the R3s, if you get 3 out of 4 of those, you're going to get at least a B. That's pretty good. And if you're really checking those carefully, it's only 4 problems to check. All right, so my advice is to check all of them on the test, but especially your R3s, because even the math teacher can screw this up, as you just saw. All right, I have another one for you to try. I'm going to scroll over here. This one, 8x squared plus 20x minus 28. I'm going to pause for a second while you give that one a try. Factor it down. Oh, you know what? I'm going to do one more thing. Equals 0. That way, once you got it factored, you have to actually solve each of those little parentheses to get your final answer. Okay, you should have noticed that there was a, not just 2, what was there in everything? 4. 4 comes out, and then I have 2x squared plus 5x minus 7. Now, if you took out just a 2, it would still work. It's just the numbers are way harder to get to factor. All right, now I'm going to go 4 and then 2 parentheses. Notice I don't try to do it all in one step. A lot of people try to do this all at once, and it's really, really hard. It can be done, but it's really, really hard. Just take an extra step. It's well worth it. And then a 7 has to be a 7 and a 1. So now it's just a matter of whether the 7 should go here or the 1 should go there, and then a plus and a minus. Miss W, what did you get? 2x plus 7. And then x minus 1. There we go. So final answer is x equals 1. And 2x plus 7 equals 0. And you just show all the little steps. 2x equals negative 7. X equals negative 7 halves. Negative 3.5 and 1 are your 2 answers. Okay. Now, what was this form right here at the top? General. What's this form right here? Factors. Is it okay to have a 4 out in front? Yes, it is. Does that 4 give you an extra root? No. If that had been a 4x, would it have given you an extra root? Yes, it would have. Okay. If I had to graph this thing now, I would have just found the 2 on a graph. Those are called the x-intercepts. As an equation, they're called zeros because they make the equation equal 0. But on the graph, they're called x-intercepts. They're also called roots on the graph sometimes. All right. Then, last but not least, if I had to make a picture of this, I'm going to pull over one of these things. Do you get, I know where its roots are? Now, in this case, do you think it would be easier to find the line that runs down the middle, axis of symmetry, by graphing it or by using that formula? Hint, if you use the formula, it's because you probably have these, A, B, and C. If you have A, B, and C, it's just so handy to go negative B over 2A. It's quick. Negative 20 over 2 times A is 16. There, I'm done. It's a lot faster than trying to see that on the graph. Besides, who knows where the heck negative 20/16 is? I guess I could simplify it, and it'd be negative 5/4, which would be negative 1.25. Oh, that'd be really hard to see on a graph. So there's times when it's better to use negative B over 2A, and there's times when it's better to put it on the graph. If they're nice whole numbers, sure, use the graph. It's easy to see a dotted line that runs between 3 and 4, 3.5, duh, easy. But if you're trying to find one where you have general form, might as well use negative B over 2A. Now, is that the whole vertex? No, that's the first part of the vertex, and then you'd have to stick that negative 5/4 into the equation, which would be long and ugly here, so we're not going to do it. All right. Now, I'm going to pause for a second and look at your Schoology quiz a little further to see what else you have to be prepared for. I'm pausing. Okay, I took a look, and there's 2 more kinds of factoring you should practice, and then you are free to just work on your Schoology quiz, probably finish it in class, Might be the easiest day of the semester if you're good at factoring. All right. So here's the other kind that they want you to be able to factor, but you might not know what to do at this point. Let's say you were told to factor that. A lot of people make 2 parentheses. Bad idea. Factoring does not require 2 parentheses. You can sometimes do it with just 1. Go ahead and factor this. So remember how I said always look for a GCF? Some of you aren't looking for the GCF. That's why you're stuck. What is the GCF? Something comes out of both of them. 2x. Not just a 2, 2x. What do you get, Sarah, then?
2x.
I can't. Okay, I can put 1 plus. Well, you're right. Sorry, my bad. X plus 1. You are correct. Okay, and then one more like that. Try factoring this. 6x squared plus 18x plus 6xa. Sometimes the only factoring you can do is factoring out a GCF. What did you see that went into everything, Mr. T? 6x is correct. Parker, what do you think is left after you pull out the 6x, which technically means divide by 6x everywhere?
X plus 3 plus a.
You got it. And do you think x plus 3 plus a can be factored more? No. All right, then the last kind of factoring they will expect you to know is this. X squared minus 36. There's no middle term. Is there anything in both of them? No. So then you just right away go to 2 parentheses and you learn a little pattern. Somebody's already got it. Raise your hand if you've got it. All right, what do you have, ma'am? Yep. What you have there is the square root and the square root and the square root and the square root. Because they were both perfect squares. X squared is a perfect square and 36 is a perfect square. All right. And let's see if you can handle this extension. This is an honors class. You can't normally factor that. Come on, somebody's going to figure this out by themselves. The question on the ACT would say, factor over the complex numbers system. Anybody think they have it? Okay, this is the part where I should help a little bit then. Do you get why this doesn't work? Because the outside and the inside are canceling nicely, and it makes 36, but it makes negative 36. How could I get an extra negative 1? Yes? So I can't just slap an I squared on one of these numbers. That would not do it. Yes? You got it. X plus 6i, x minus 6i. Why does that work? Well, the outside and the inside still cancel, right? But what do these last two make when you multiply them? Yes, they make an extra I squared, which throws in an extra negative 1. Now your negative 36 turns to a positive 36. That is factoring over the complex number system. All you had to do is throw an extra I on it. You have to know why. Because the I times the I will make an I squared, which gives you an extra negative, which will make this come back to positive 36. All right, so let's see if we can put that all together into this beast of a problem. Ready? 4x squared plus 16. Factor over the complex numbers system. I would bet you money that none of the honors higher algebra classes are doing this today except yours. Because I know this is on the ACT. Not every time, but I've seen stuff like it on the ACT. And this is a perfect day to add this in because we're just factoring with GCFs in front and with a lead term that's not 1. So in other words, there's like not only a 4 factors out, but anyway. And then also we could throw in the last chapter, which we had, which is complex numbers, and produce, did anybody catch that 4 came out and it's x squared plus 4? Raise your hand if you notice a 4 came out. See, a lot of people don't look for that. You gotta notice right away that there's a 4 in both of them. That's a GCF. All right, now take it from there if you haven't already and get me a final answer. Raise your hand if you are finished. Okay, that's not many, so I'll give you another 30 seconds here. You've got it. Can you read it to me? The problem with that one is you have a 4 in front, and so you'll end up with bigger than a 16 at the end. You were close, but something went wrong here, and I noticed you had an answer, but I didn't notice that there was a mistake in it. I wouldn't have told you to read it if I didn't notice there was a mistake in it. But there is a mistake in it. Do you know what your mistake is already? Okay, 4 times 4 isn't 4. I times I also isn't 4. You're getting close. Somebody else take it over. Somebody else must see this. What do you say, sir?
X plus 2y in parentheses, and then another set of parentheses, x minus 2y.
Yes. 2 times the 2 makes the 4. And I know you might have been thinking 16, but there's a 4 in front that has to also multiply by this. So you can't use a 4 and a 4 in here. X plus 2i, x minus 2i. Then, if you wanted the roots, well, what would make this part 0? Negative 2i. What would make this part 0? Positive 2i. So the roots are plus and minus 2i. Sound like something you would have gotten out of the quadratic formula because it has plus minus in it. And then there would have been a negative underneath the root. And how could I have done that? I could have set this equal to 0 and said A was 4, B was 0, there wasn't a B, and C was 16, and it would have worked. All right, I've checked over your Schoology quiz. We've covered everything that's in there now. You should be able to do it. So take some time, get some quality work done on your Schoology quiz. Once you're done with that, feel free to work on whatever you'd want. And that's all I got for you for the video for today.